After all these, we have still some more points about the case control studies. And in the analysis for the case control study, the odds ratio is a good estimate of the relative risk when the disease is rare. We mean disease is rare, that means the prevalence of the disease is less than 20%. And we cannot only include only one control for the case control study. We can include several controls, but when we include more than 5 controls for each case, it will be not that efficient. And the statistical testing for the case control study analysis is by the simple chi-square test for the unmatched analysis, or by the McNeil's chi-square test for the matched paired analysis. So when we measure the association between the exposure and the outcome, if some characteristics are not comparable between the cases and the controls, some factors might bias the effect measure of the association. That's the confounding problem. In case control studies, potential confounding can be controlled by restricting or matching in the design stage, or by the statistical treatment in the data analysis stage, such as the stratified analysis or multivariable analysis. For the stratified analysis, we can use the Mental-Hansen chi-square test to show the association, to test the association between the exposure and the outcome, and controlling the effect from the strata. Let's see details about the stratified analysis. So, a stratified analysis is a technique to control the confounding factors that involves the evaluation of the association within the homogeneous categories or strata of the confounding variable. It is possible simply to report the unconfounded relative risk or odds ratio estimate for each stratum and calculate the confidence interval around each estimate. It is also useful to calculate a single or summary estimate of the association between exposure and disease once the effect of the confounding factor has taken into account. Evaluating as the similarity of the stratum-specific estimates, we can either by eyeball or perform a test of statistical significance. If the effect is thought to be uniform, then we can calculate a pooled unconfounded summary estimate using the Mental-Hansen odds ratio. And the hypothesis testing should be the unconfounded estimate, based on the unconfounded estimate should be the Mental-Hansen chi-square test, and we can also use it to compute the confidence interval. If the effect is not thought to be uniform, which means that effect modification is present in this study, then we should report stratum-specific estimates. So there are several principles to consider about the confounding factors when we want to do this stratified analysis. However, the presence of or absence of the confounding factors should never be assessed by a statistical test of significance. Large sample size could easily result in a statistical significant association between the confounding factors, and the exposure or disease. Even the magnitude may be too small to result in any material amount of a confounding effect. On the other hand, even strong association that could produce a confounding effect of substantial epidemiological importance may fail to reach statistical significance with small sample size. So significance test can be used, however, to evaluate whether the unconfounded effect of the unconfounded estimate of the effect differ from the no value of no association. Now let's talk about the bias in the case control studies. Bias is the systemic error occurred in the epidemiology studies. Among these biases that in the epidemiology, there are 3 major types of bias: the selection bias, the information bias, and the confounding bias. Let's first see the selection bias. So selection bias is that the relationship between the exposure and the disease observed among those who participate in the study is different from that for individuals who would have been eligible to participate but were unwilling or not selected by the investigator. For example, Concerns about the existence of selection bias are always raised when response rates are either low or unequal for cases and controls, since those who agree to participate are different from those who do not in a way that may be related to the exposure and outcome under investigation. Similarly, if alternative controls are selected to replace those who were originally chosen but would not be contacted or refused to participate, biased estimate could result. There are two particular types of selection bias for case control study. The first is the Bergson's bias. It is a type of selection bias which can arise when the sample is taken not from the general population, but from a subpopulation. It was first recognized in case control studies, but both case and controls are sampled from a hospital rather than from the community. When we take the example, we have to assume that the chance of admission to hospital for the disease is not affected by the presence or absence of the risk factor for that disease. This may not be the case, especially if the risk factor is another disease. This is because people are more likely to hospitalize if they have two diseases rather than one. The second one is the Newman's bias, which is also known as the prevalence and incidence bias. Newman's bias is a type of selection bias in a case control study which is caused by the prevalent cases. If only prevalent cases are used, prognostic factors might be mistakenly inferred as the etiological factor. There's another bias called the detection bias. Detection bias due to the closer medical attention, detection of such as the detection of endometrial cancer, who are more will be in a group using extra genes. The second is the information bias. Information bias is also termed as the observation bias or measurement bias, which results from the error obtaining information from the subjects once they have entered into the study. This type of bias may arise because information on exposure is provided by the participant or a surrogate or proxy respondent after the onset of the disease. Knowledge of the disease status thus may influence the reporting of information by the subject or the recording or interpretation of this. There are still two types of information bias, recall bias and misclassification. Recall bias relates to the difference in the ways that exposure information is remembered or reported by the cases who have experienced an adverse health outcome, and by controls who have not. When people remember past events, they don't usually have a complete or accurate picture of what happened. In fact, it's been shown that our brains continuously rewrite memories, clouding them with current events or even editing them completely. Memories can also be distorted by shock at the time of an event, post-traumatic stress disorders, or any other type of disease and conditions that affect the brain. Recall bias cannot be corrected after a study has been completed. The second one is the misclassification bias. Misclassification refers to errors in the categorizing of either exposure or disease status. Such errors are inevitable in a study, but the consequences of this type of bias depend on whether the misclassification with respect to one axis, either the exposure or the disease, is not independent of the classification of the other axis. Differential misclassification happens when the information bias differ between the groups. In other words, the bias is different for the exposed and non-exposed people, or between those who have the disease and who do not have. If there is a non-differential misclassification, then the information, even though the information is incorrect, it will the same for different groups. It happens when exposure is unrelated to other variables, including the disease, or when the disease is unrelated to other variables, including the exposure. While the bias introduced by the non-differential misclassification is usually predictable, as it would go towards the null value, but it is not always the case. 3 or more exposure groups can cause bias away from the null. The last type of bias is confounding bias. Confounding is a distortion or inaccuracy in the estimated measure of association that occurs when the primary exposure of interest is mixed up with other factors that are associated with the outcome. Methods for addressing the potential confounding factors in a case control study include restriction or matching in the design phase, and stratification and multivariate techniques in the analysis stage. However, no single method can be considered optimal in every situation. Each has its strengths and limitation that must be carefully considered at the beginning of the study. In most situations, a combination of these above strategies will provide the better insight into the nature of the study and the more efficient control of the confounding factors than any single approach can do. Now, let's take a look at the strengths and weakness for a case control study. The strengths for a case control study that the most important strength is that it can deal with the disease with rare prevalence or incidence. Because if the disease has the rare number of cases, either descriptive or cohort study cannot study this kind of disease. The second strength is that there will be a long tendency between the exposure and the disease. Since there's a long latency, then we can observe the long time exposure and the disease association. It can also explore multiple exposures for a single outcome, because we select the outcome as whether the participants have a disease and restrictively obtain the information on different types of exposure, so that we can explore multiple exposure for a single outcome. And it is also not that expensive, and we can do it very fast when we want to do the case control study. There are also several weaknesses for the case control studies. The first is that it's prone to some biases. There are several biases that can be illustrated in the case control study, and the most important is that it has some recall bias, so that some involved information may not be that accurate in the study. The second weakness is that it has a temporal relationship cannot be established, because we have first find out the outcome and then retrospectively find out the exposure. So the temporal relationship between outcome and exposure and cause and disease are restrictively, and this is not the usual causal thinking that the cause and outcome should be in a right temporal order. It is also not efficient when we want to study some rare exposure, unless exposure often lead to that disease. Because if there is a rare exposure, then it's very difficult to explore that exposure. In the next slide, we have illustrated the difference between the case control study and the cohort study. So we can see that case control study proceeded from the effect to the cause, and this is the same as the cohort study. While case control study start with the disease, but the cohort study start with people exposed to some risk factors. The case control study tests whether the suspected cause occurred more frequently in those with the disease than among those without disease, while the cohort study tests whether disease occur more frequently in those exposed than those who does not have this exposure. Case control study is usually the first approach to test a hypothesis, but also used for the exploratory study, while cohort study is mainly used to test the formulated hypothesis. Case control study involves very few number of subjects, while we need a large number of subjects in a cohort study. And case control study will really yield relatively quick result because we will done it very quickly, while cohort study needs a very long follow-up period after we start the cohort, and it will also involve some delayed follow-up. So case control study is very suitable for the study of some rare disease, while cohort study is inappropriate when the disease or exposure under investigation is rare. In the case control study, we will calculate the odds ratio, and in the cohort study, we can calculate the relative risk, absolute risk, and also incident rates. The case control study cannot yield information about the disease other than the selected for the study, while cohort study can yield more than one disease outcome. That's the temporal association between the disease, the exposure, and the outcome disease is more proven can be in the cohort study. And recall bias is only seen in the case control study, while in the cohort study, recall bias is not an issue. And we can see the last characteristic difference is that the case control study are relatively inexpensive, while cohort study are usually very, very expensive.